Okay, so this afternoon we're actually going to get started on some software developing. So let's get going. So I can see my problem with the screen tearing hasn't solved it. I tried to work on that over lunch, but it seems there's still something standing in the way. Sorry about this. We'll carry on and make the most of it. So this is one of the longer sessions. I think we're due to finish this session at, I believe, 2:15, is it? Yes, so we'll carry on until 2:15 and then have our afternoon break. So just now, we'll take a look through the ARCHER2 development environment, which is essentially the HP Cray development environment. Find out which compilers and tools are available, how to access and use them. You can see how to also get help with compiling these, compiling your software on ARCHER2. And at the end of it, we would like to know how to access different parts of it using its LMOD modules now. So if you've been using the 4-cabinet system, or if you are a user of old ARCHER1, this is different. And know how to find out what is installed and where to get help. So software modules on ARCHER2 are provided using the LMOD system. So you are probably aware of modules in general. If not, a module is basically a file that's somewhere on your system, and using the module command, you can tell it to load or unload these files, these module files. You just see them as modules, and these add different pieces of software into your environment to use, different versions of different pieces of software, different tools. LMOD is the specific version of modules that we have now ARCHER2 on the 4 system. Previously, we used TCL modules. Now we've upgraded to the newer LMOD. The L here stands for Lua. If you've ever heard of or used the Lua language, that's just because the modules now are written in Lua. Something to note is that you shouldn't expect these to be static. As with all pieces of software, they're constantly being upgraded, extra functionality is being added to them, bugs are being fixed. So you should expect new versions of these to come out. And if you compare the module versions that were available on the 4 cabinet to what's now on the 23 cabinet, you'll see that the 23 cabinet system has newer versions of lots of pieces of system software. And also CSC provided software that essentially upgrade what was there, improve performance, fix bugs. So when you log into ARCHER2, you'll start off with some modules already loaded. So some pieces of software will already be in your environment. Their binary, their bin directories will already be in path. Their libraries will already have been added. The location of their libraries will have already been added to LD library path and so on. So they're ready to be used. Main ones are the Cray compiler environment. So this is Cray's own C, C++, and Fortran compilers. The Cray MPI library. The libsci libraries, this includes LAPACK, SCALAPACK, the like. Also, the lightweight version of the performance analysis will be there. And certain system modules which are needed for those to actually function. So let's bring over my terminal. And if you have your own terminals, you can, of course, follow along with this. let's just get some new clean lines. And we're just going to work through some of the basic commands needed to work with modules. So the very first one we're going to try out is module list. And we can see the output on the left, but here it is again. This just outputs the modules which are currently loaded into the environment admin. So I've been logged in previously, but I haven't changed any modules. So these are just the default ones available when you log in that have been loaded. So there's our Cray compiler environment. So we've got version 11.0.4 installed of Cray's compilers. Cray PE, x86 Roam list. These are parts of the system modules to just help everything work. Same for libfabric, Cray PE network OFI, xpmem. A lot of these are ones that you shouldn't have to worry about, that simply help everything to work together. This is kind of a feature of Cray systems. They come with a lot of their own software that works in a very interconnected fashion. Yes, can you see them on the right? You should be able to see the list of modules. I've highlighted it now. Is that coming through to you, frozen for you? Okay, let me stop the screen share and try again in that case. Okay, sorry about this, just give me a minute. Let me just attempt this. Okay. And where is this? Let me see if this works a little better. Okay, let's see if this improves things at all. Sorry, I'll just be back in a second with the screen share. Okay, let's share it once more. Okay. Okay, can you see this now? Okay. It's still half frozen. I think this is what I get for living in a house with thick old walls. Can you at least see the modules that have been loaded on the right? Okay, great. Okay, fantastic. Okay, so this is the first command we want to use, module list. It just shows us everything that's been loaded. Some of these are things we should worry about. CCE is our Cray compilers. We can see which version of mpitch we have loaded, Cray mpitch, and which version of libsci. So when you log in, by default, everything is configured that you'll jump in with the Cray compilers loaded. Some people sometimes expect that when you log in, you'll have the GCC compilers loaded. That isn't the case. So we'll talk about how to switch to those in a minute. Something to note is that you may previously have used the module purge command on other systems you may have used in the past. If you find you've ended up with a set of modules loaded which you didn't want to use, then that will, on some systems, get you back to the clean default state. But because on ARCHER2, as on all clay systems, HP clay systems, they come with this suite of software that has to be there for things to work. If you try and do that, you may break your environment. So really the thing to do rather than that is you can run module restore. So you would just do module restore, and that will bring you back to normal. And if you really do break things, really the thing to do is to log back out and then log back in again, and you should find that you're back with the default set of modules that do work together. So we can see how to see which modules are available at the moment. But of course, the whole point of having the module system is to allow us to switch and change modules. Maybe we want to use GCC rather than the Cray compilers. Perhaps we want to use a specific version of a library rather than the default. So for that, we need to find out what's actually available, and that's done with the module avail command. So if we run module avail, the top of my monitor is still frozen for you, but you can hopefully see module avail. If I scroll through it on the left, will provide a whole list of all the software that we can load at the moment. And you can see, so here are some of the pieces of simulation software. So you might want to use CastStep or CodeSaturn or OpenFoam if you just want to log in and run a job. We've got some post-processing tools, NCL, Wizardata, XTHI we'll use later on. It's just a simple MPI program. And then we're on to the Cray software. Most, but not all of the Cray software begins with Cray. Okay, so module avail is the command that we use to find out what's available, what can we actually load if we want to change our software setup at the moment. I mean, that's actually a short command for module available. If you run this, you find the exact same output, but avail is, well, it's just shorter. You might notice we've got some D's and L's in brackets here. So we can see CPE 21.04 is D, Cray R 4.0.3.0 is D. These mean that these are the defaults. And we've also got some in these highlighted L's, yellow L's, which means that those modules are loaded at the moment. Licensed software we spoke about actually just before lunch. So if you want to use VASP or the like, you have to be able to provide a license. Before you do that, that's done through the safe. And we talk about that in a little bit. So, so if you were doing module avail and noticed that, oh, I think I've gone past it, that VASP is available, and you happen to want to run some VASP jobs, then you would be able to use that, but only after you provide the VASP license through the safe, which then gives you group access to that. Can check what we have with module list. That tells us what's loaded at the moment. Module avail will show us what is able to be loaded at the moment. And yes, and we can see defaults with D, and we can see what's currently loaded in module Avail with these Ls. If you want to know more about a specific module, well, something you can do is you can use module help. So module help cray mpitch will allow you to, well, in this case, it goes through a lot of licensing information, limitations. There's some information, and module what is are also helpful, is also helpful. So again, module what is cray mpitch will give us some information. It kind of depends a little on which module you're looking at to see how much information comes from help and how much comes from what is. Ultimately, though, I would say if you want to know more about a module, probably the place to look would be on the ARCHER2 documentation website. So we know how to find out what is there. At least we can use module Avail to find out which software is available for us to look at and use. If we want to actually use something, well, module list will show us what we have at the moment. Then module load cray fftw would be the command we would use if we wanted to load the HPE cray installation of fftw. So this is the special software developed to run as performantly as possible on systems like ARCHER2. So if we just do module load cray fftw, that runs, we don't get a message. We can then check again with module list, and we can see at the bottom, we've now loaded cray fftw 3.3.8.9. As for that, what that actually means in terms of using FFTW, the cray FFTW software, we'll see in a little bit. Something else to note is that specifically it loaded version 3.3.8.9. So we didn't choose a version. If we do module Avail cray FFTW, that will show us the version specifically that are available of this alone. Module Avail with no arguments shows us everything that we can load at the moment. If we give it the name of a module, so cray FFTW, it will show us only versions of that module. So we can see that cray FFTW 3.3.8.9 was available, and it was the default. So when we ran module load cray FFTW, it just loaded this default. But there is also 3.3.8.11. If we wanted to change from one to the other, we say, well, we've loaded 3.3.8.9, but we actually want the other version. One way to do that would be to do module unload cray FFTW, and it will just unload the one that we have loaded at the moment. So if we do module list, it's disappeared. And we could then do module load cray FFTW 3.3.8.11. And that then loads that specific non-default version. Another way to swap between them is to use the swap command. Swap just essentially combines the unload and load commands into one. So if we want to swap back to the original version, 3.3.8.9, we could do module swap cray FFTW 3.3.8.9, sorry, 3.3.8.11, and cray FFTW 3.3.8.9. And that will unload 3.3.8.11 and bring us that new one. And this actually gives us a little message to tell us that we've swapped versions. Finally, there's a little convenience command, it's called ML, which is just a shortcut for both module list and module load, because these two commands are used so often that having a little shortcut command is actually pretty helpful. So if you run ML by itself with no arguments, it just acts as module list and shows us what we have loaded at the moment. Move that over a wee bit, make it a wee bit bigger for you all. It just shows us, yes, what we have loaded at the moment. If we do ML with an argument, it then loads some things. So let's try, I don't know, ML cray HDF5 will load default version of the cray HDF5 module. And if we do ML again with no arguments, it will show us that we have that now loaded. And again, if we want to go back to a pristine environment, we'll just do module restore. And that now, well, let's just do ML again, shows us that we're back to what we originally had when we logged in. Something new here that is different from the ARCHER2 4 cabinet and any other systems you might have had which used regular modules rather than LMOD are hierarchical modules. This is something introduced by LMOD as a way of taking care of dependencies between modules. If you imagine that you might want to use a tool or a library or an application which depends on something, on some specific version perhaps, or a specific type of MPI or any very specific module, then you need to make sure that you can only load the module for the software if you have the previous one installed. So not installed, loaded. So that's what hierarchical modules are intended to do. And the way it kind of works is that it sort of hides things until the correct dependencies have already been made available. So one example we'll see here is that the cray netcdf installation on ARCHER2 has actually lots of different installs in different locations on the file system, but each one was built with a different version of cray HDF5. And what you would want to do is you would want to make sure that for the version of cray HDF5 that you need to use, you then have the correct version of cray netcdf installed. You could do that yourself. You could ask the users to do it, but it would be a bit messy to say, okay, if you load this, then you've got to load that. The hierarchical modules take care of it for you. So what we've got to do is essentially load whichever version of cray HDF5 we want, and then the correct cray netcdf module will become available as well. So to try it out, let's see if we can find netcdf. So if you just try and do module avail cray-netcdf, you should find that it actually doesn't find, well, it only finds these two sort of these two installs from EPCC, but it doesn't actually show any of the cray netcdf installs, but they do exist. So on top of the regular module avail command, which shows us which modules are available to load at the moment, we can also run the module spider command. And module spider acts to, if you want to envision it this way, sort of walk the web of dependencies and just show us everything. So module spider will show every module that can be loaded at all, no matter if we're actually able to load it or not at the moment. So if we do module spider cray, module spider cray netcdf, this then shows us that there are actually two CRANet CDF modules available, but because we don't have the dependencies for them available, we can't actually see them in module Avail and we can't load them. So if I tried to do module load that, it will say you can't do it. Lmods detected an error because we haven't actually set up the dependencies that we need. So we've got two versions available. So if we want to find out how to actually load this, well, we'll run the command. It's here on the page, on the material for the course, and lmod is suggesting it here on the right in the terminal. If we run module spider CRANet CDF and then the version we care about, it's now actually going to tell us what we need to do to load it. And it's going to tell us you will need to load all modules on any one of the lines below before it can be loaded. So it's saying we could load any one of these lines. If you look the first column, AOCC, this is the AMD optimized compiler collection. So this is the AMD compilers. CCE is the Cray compiler suite, and GCC is obviously the GNU compiler collection. So that first column are all the different compilers. The second column are just different versions of Cray HDF5. So this is saying, essentially, before we can load CRANet CDF version 4.7.4.3, we have to load both a compiler, and we know we've got a compiler loaded already. We've seen it when we ran ML or module list. We've got this, we have CCE 11.0.4 loaded at the moment, and we also have to choose a version of Cray HDF5. So the issue is that until lmod knows which compiler we want to use, and also which version of Cray HDF5 we want to use, it doesn't know how to load CRANet CDF 4.7.4.3, which depends on both of those. So what we can do then is we can just load, say, version 1.12.0.3 of Cray HDF5. So let's just do ML and then that's module, and that loads it. And if we just run ML again, we'll see we've got that loaded. We also had CCE version 11.0.4 loaded right from the beginning. That's the default compiler that's loaded on login. And we can now then do module Avail, CRANet CDF. And because everything that's needed to load it is now there, it can tell us, there it is, it's available to be loaded. So we can just go ahead. If we just do this, that's the default one. So we can just do module load CRANet CDF, and it's loaded. Let's just do module list. Let's just switch back and forth between using ML and module load and module list. If we do module list, then CRANet CDF has now been loaded. So this can be, I think this can be a little confusing the first time perhaps that you come across hierarchical modules doing this, because you might log in and expect to find something to be used, and module Avail just doesn't show it to you. At that point, just try using module spider and then check out module spider module name / version number, and it will tell you, like as not, that it's there, it can be loaded, but you just need to make some decisions as to which versions of things are going to be used first, and then it can load it to be used properly. Yeah, so yes, if you can't find it, try using module spider instead of module Avail. Okay, does that make sense to everyone? I'll give, if anyone has any questions about that, I'd say please speak up now, because I know this can be a little tricky to get your head around at the start. Okay, so if you want to list everything via Spider, you just do module Spider with no arguments, and this just shows you absolutely everything. Of course, that means it's also pretty long, but if you just want to see everything available on the system, whether you're actually able to load it right now or not, just do that. And then once you've found what you want, again, just do module Spider and then the name/version of that module, and module Spider will tell you if there's anything to be done before you can load it. Okay, so switching now between programming environments. So we've seen how we can use module load to load particular modules, but it's also used to switch between what are called programming environments. So this is some HPE craze speak, sort of, for the complete selection of compilers and supporting libraries that are to be used to build software. And essentially, you can sort of imagine, think of them as tool chains, if you like. And they come in three broad flavors of the Cray, GNU, and AMD programming environments. And these exist as, well, they have these three names here: progenv Cray, progenv GNU, and progenv AOCC. So if you used Archer in the past, you would have been familiar with loading and swapping these around. If you used the ARCHER2 4 cabinet, you will have been aware of how these were module collections, as they're called, which are to be module restored. That's changed again, so they're now regular modules once more. So these can be loaded and swapped just as before. So if we do module Avail progenv, I think we should see them. Yes, we do. So module Avail progenv shows we've got 6 progenvs available, so 6 programming environments, 2 for each of them. They're just slightly different versions, version 8 and version 8.1.0 for each. And these are the main way of saying, when you're on ARCHER2 and using it, I want to use, say, the GCC compilers, or I want to use the AMD compilers. By default, if we do ML, we'll see that when we log in, we're given by default progenv Cray. So that's the default when you log in. That means that if you start building on ARCHER2, right after logging in, you will be using the Cray compilers. But you can change them, change between them by just doing module load, or you can do a module swap, maybe a cleaner way of doing it. We can do module load progenv GNU, and that will swap us into the GCC environment. And you can see as well that 3 modules have been changed. So both Cray HDF5, Cray HDF5, Cray NetCDF, and Cray MPitch have all been reloaded now to take account of the fact that we don't want to use the versions of those libraries that were built for use with the Cray compilers. The LMOD system is intelligent enough that it's saying, okay, let's swap these out and then bring in different versions of the modules with the same name that will work correctly with the GCC compilers. And the other way of changing is to just do a module swap. So it might be a little cleaner. You would say module swap progenv GNU to progenv, let's just go back to Cray. You would do it just like that, and it changes it back again. And at any point, remember, you can ML and take a look at which progenv module is loaded. So that's how you change between the Cray and GCC and AMD compilers. You may also wish to swap between them. So let's do module swap progenv Cray, and we'll swap to progenv GNU. So we've changed to using the GCC compilers. And if we do ML, we'll see that we've now got loaded GCC version 10.2.0. If we module Avail GCC, we'll see that we've actually got a few versions available: 9.3.0, 10.3.0, 10.2.0, and 11.2.0. And what you can do once you're in the correct programming environment is you can then module swap. And let's just change GCC. So GCC here without a version just refers to whichever version of GCC we have loaded. And then we're specifically going to replace whatever version we have loaded with version 11.2.0. And that makes the change for us. So at this point, if we went ahead and started to build with GCC, we'd be using 11.2.0 rather than 10.2.0. So this will work. You can do this. I'm not sure I personally would always recommend it. You may run into some edge cases where things don't quite work together as they should. Again, remember, because the HPE Cray software works together very closely as a whole, it may be that because you've just loaded the swapped out the default version of GCC for a non-default version, that some other library or some other module may be caught out by this change in version. The way it works is that Cray release what they call a Cray programming environment, so a CPE release, and each CPE release has the type of compiler. So GCC, it says it's going to have this version of GCC, and we're going to release these versions of Cray HDF5 and Cray NetCDF and Cray FFTW, Cray libsci. And we're going to release all of that as a coherent set of software which will work together. The modules will play well with one another. So if you load a programming environment, it will set itself up for that CPE release. If you change the compiler version to something else, to another version, particularly if it's a very different version, you may find that things don't actually work together. That should be an edge case, but it can happen. So what you do instead is you load a CPE module, and we can actually see that. If we take a look here, we should find, oh no, we didn't. I think we did have one when we originally logged in. So you don't need to have a CPE module loaded. But what we can do definitely is if we do module Avail CPE, we should see them available. Okay, here we go. There's CPE CUDA there. I have no idea why that's there, because it certainly isn't going to be useful on a system that doesn't have NVIDIA GPUs and never will. But we do have two CPE modules here, 21.04. They're just named year and month. So this is the April 2021 release, and this is the September 2021 release. You can see we've got the default loaded, or rather the default to work with is 21.04. And we can just switch. We can just do module load CPE 21.09, and that will change everything over to that coherent set of software released as part of version 21.09 of CPE. So you can see we've changed from the programming environment, version 8 to 8.1.0. We've changed HDF5, libsci, mpitch, netcdf, and CRAE-PE versions. We've changed all of these. Finally here, just to make sure that everything's working, you should just then run also this export LD library path, and this just adds the CRAE LD library path in front, just to make sure that you're working with the updated libraries. Okay, so at this point, we've spoken a lot about modules, We haven't actually spoken about how to use the compilers and the libraries. If you're unfamiliar with CRAE, the CRAE programming environments, you may not have come across these before, but everything on CRAE systems essentially runs to a compiler wrapper. This works just the same as if you were building an MPI code in C or C++ or Fortran. You would expect that you wouldn't just do GCC, then the name of your source code files, any options, name of output file. Instead, you would be expecting to call something like MPI-CC or MPI Fort or whichever. And you would know that those are compiler wrappers, and those compiler wrappers just make a call to the compiler itself, to GCC or whichever, or ICC if you're using Intel, but it acts to add on the extra flags needed to tell the compiler where to find the MPI headers, where to find the libraries, any extra options that are needed. And the CRAE compiler wrappers work in the exact same way. When you call them, they fold in all of the options needed to tell the compiler where to find the MPI libraries and headers, but it also folds in all the options for any of the other pieces of CRAE software. So at the moment, if we were to call just here one of the compiler wrappers in our terminal, well, we've got netcdf loaded, we've got mpitch, libsci, hdf5. If we were to call the CRAE compiler wrappers, it would fold in all of the options needed for us to build against all of these libraries without us having to take care of that ourselves. As for the names of them, they are FTN for Fortran, CC in lowercase for the C compiler, and for C++, CC uppercase. And the modules, again, will change these scripts. They pass through a set of environment variables, and they make sure that these will link in the correct libraries and set the correct options, and that they will also call the correct compiler itself. So when you have the when you have progenv CRAE loaded, if you're in the CRAE environment, then these would call the CRAE compilers, the Fortran C, C++ compiler respectively. If you were in progenv GNU, then they would bring in GCC, GCC, GFortran, G++. And again, if you were using the AMD compilers, they would do the exact same thing and call in the correct compilers to be used. And onto all of them, they would use the correct options for that library. They work perfectly fine with both serial and parallel code, so you don't need to worry about adding extra flags to tell it to do a particular build in serial or a particular build in parallel. It will work just fine. What this does mean, and this is again a big thing that can sometimes trip people up when they're first starting to use an HPE CRAE system like this, is that when you're doing a build, you should always try to use these compiler wrappers. they're the default way of building. Everything on the system is constructed under the assumption that you'll be doing the build with them. And that's because it takes care of all of the link lines, all of the options for you. Because all of this works so tightly together, if you try to actually do this yourself by calling GCC or the like directly and then adding the options to tell it where the libraries are and so on, you will probably be left scratching your head for quite a long time. And there is no benefit to doing that over just using one of the compiler wrappers. So you should always, if you have a build system, a makefile, or if you use CMake or anything at all to automate your builds, you will need to change them to use FTN, CC, or uppercase CC respectively. And unless, of course, your build script is already intelligent enough to work out it's on a Cray system and switch to using them automatically. But this generally means, digging into your make file or whatever and just changing the correct variables to tell it to use the compiler wrappers. And then once you've done that, you don't need to worry at all about telling it where to find any of the system software, mpitch or libsci or the like. Those compiler wrappers will do the work for you. So, I mean, I can quickly show this. So we had progenv GNU loaded at the moment. So if I do ftn -- version, we'll see it's telling us that it's running GNU Fortran. If I do module swap progenv GNU, and if I load progenv, let's just go back to Cray again. If I do ftn version now, it now tells us that it's using Cray Fortran. And whenever we do that switch, everything's changing so that it's now going to be using the correct modules and the correct paths for the libraries and the like. Again, I mentioned the man pages earlier. They're always handy to look up quickly if you just want to check something. So you can always just do, so again, in the example of ftn, you can just do man ftn. And if I scroll so you can see it, that tells us that, that ftn invokes the Fortran compiler in the currently loaded programming environment. And then we can scroll through, take a look at the help for it, take a look at the options. But at the same time, also take a look at Cray FTN. And that's now giving us the help specifically for the Fortran compiler itself. So the man pages are different for the compilers and the compiler wrappers. And as you'd expect, the man pages for the compiler wrappers give you help on using the wrappers and specifically the wrappers. So any options that can be passed to the wrappers themselves, which will work in any of the programming environments. While if you then were to look at man for GCC, if you had the GNU programming environments loaded, of course, that's going to tell you the options that are specific for that compiler and which will only work in that programming environment. I think we're very nearly at the end here of this session. So ARCHER2, all linking there is dynamic by default, and in fact, it only supports dynamic linking. This is another change from Archer, where everything was static by default. There are a few reasons for it. Something that is nice is that part of this change in the HP Cray software to dynamic linking means that we have we can now make use of run paths in executables. So a run path means that the locations of the libraries can be encoded into the ELF header of your executables or your dynamic libraries. And so when they're run or loaded, the dynamic linker can read that and know where to look for the libraries without those libraries locations having to be in the LD library path environment variable. So this means you can build things, and often you can get away with not having to load the modules to correctly provide the libraries for it. If you do that, it will still work, and you can also override those libraries. A lot of the time, this isn't something people want to worry about, but it's background information if this is something which matters to you. Something I should note, yes, is that the extra libraries provided by the ARCHER2 CSC team at EPC, because this is extra software built on top of the system software. It's not part of the Cray programming environment release. This is extra material, extra libraries, tools on top. Those paths are not captured in the run paths. So you do need to load them if in your job scripts, if you need to load anything from us to build your executables. Generally, a way to check if something's going to work or not is to do an LDD on your executable and find out if the correct libraries are going to be loaded in or not. Finally, again, I mentioned the ARCHER2 documentation is pretty complete. It's a good resource. So if you want to know more about this, definitely have a check, have a read through it. And that includes information on all the software that we have on ARCHER2 that is made available centrally. So this is everything which is available through module files, but please remember you can absolutely build whatever code you want yourselves to use on ARCHER2. And yeah, and if you're having issues, please email the ARCHER2 service desk. You can find the link there. It's on the ARCHER2 webpage. Get in touch with us. And if it's something simple, then we can hopefully get it sorted out for you quickly. But we're very happy as well to help if you run into some really big issues and need some help with those. So the key points before we end are that we control the development environment through LMOD modules, so Lua modules. We support all GCC and Cray and AOCC. That needs to be added in there. So we also support the AND compilers. They should always be accessed through the compiler wrapper commands, ftn for Fortran, cc lowercase for C, and cc uppercase for C++. And if you run into issues, please get in touch, and the CSC service will be very happy to help you out. Okay, there's a lot of information in there on the development environment, so we're about to head on to our afternoon break. Does anyone have any questions about this at the moment? Okay, I think we've got one here. Which compiler is better, AOCC or Cray? I mean, that's a subjective question, I guess is why you put it in speech marks there. I actually really quite like the Cray compilers, I have to say. I've been doing some testing of them on ARCHER2 on the full system before access was opened, and I was getting some really good results with the Cray compilers, even ahead of the GCC builds I was using. I'm imagining this is purely because Cray, well, it's their hardware that they've developed. They know what has to be done to get things to run quickly. AOCC is also, I think, perhaps not quite as mature at the moment. But even the Cray compilers, they've made some fairly big changes since ARCHER2. So on ARCHER2, they used their own versions for all three compilers. All three Fortran C and C++ were entirely their own builds, their own source. With the newer software, which includes all the software on ARCHER2, they've actually changed things up a little bit. So they're still using their own version of their Fortran compiler, but their C and C++ compilers are now based on Clang, on LLVM Clang. They've done their own tweaking on top of it, so it's their own fork of it. They've kept some of the arguments and the like to match what they had previously with their own versions of the compilers. But the actual software itself is I think heavily tunes Clang, but it seems to work really well to me. AOCC itself is also Clang based, so they've actually got a lot of shared heritage there. But at the moment, personally, I think, without wishing to put the AMD people down at all or anything, I think I would say Cray is probably better for stable builds and the like. But absolutely, please go ahead and test out AOCC if you're interested, and you may well get some good results there as well. Certainly, the AOCC compilers are tuned for the hardware, as I think at the moment Cray sort of have them edged out a bit in terms of taking advantage of the whole package rather than just the processors. But that's again a little subjective. But yeah, I'm very happy with what I'm seeing with results from the Cray compilers. Hey, does anyone else have any questions just now? Have I faced some problems with Cray compatibility with GNU compilable code? I haven't personally, but I believe some people I work with have run into some issues here. Really, if code is standards compliant, then on the whole, that this shouldn't happen. So if this is happening, it's really an issue with the code itself if it leans too hard in some feature which is only available and through some compiler. But personally, I've built how many? I think I've built 5 or 6 pieces of that CSC list of software. I think are ones I'm responsible for, and actually, I think the only issue I came across when changing compiler between GCC and Cray was that the Cray Fortran compiler was doing some odd renaming of Fortran module files, which I wasn't able to. Well, I could partially fix it, but in the end I gave up and decided it would be quicker to just rename them myself. Thankfully, there were only, I think, 2 or 3, and it was very easy to see what had happened and to fix. So that's the only issue, but that's sort of outside the standards, I think, a little. It's up to something. So I'm imagining it was something in the build script was too heavily tuned one way or the other. But overall, I found moving between them very easy. In fact, probably even beyond easy, I'd say essentially effortless for the most part. You're very welcome. Yeah, I mean, probably the main thing to be aware of when moving between them, if you do want to test out Cray and then GCC, is to be aware of the different default levels of optimization and the different flags to use for optimizing. I think that's no. In fact, I know that's all on the ARCHER2 docs website. It discusses what the default levels of optimization are and what you might like to try out to get started. So I would take a quick look at that if you do want to run comparison tests possibly between the two. But really, that's, I think, the main thing to be aware of, just the fact that because they are different tools, they have different options and flags to do the same thing, essentially. Okay, with that then, I think we'll call it there then for 15-ish minutes, just a little under 15 minutes. Sorry, my internet problems, I think, slowed us down too much there. So we'll take a slightly under 15-minute break. And we'll come back to get started again at 2:30, and we'll begin the final session then on actually running jobs on ARCHER2. So we're going to write some batch scripts in Slurm and submit some XTHI jobs to take a look at how processes and tasks are placed on the nodes. Okay, great. I'll see you all then in 12-ish minutes. Hi everyone, welcome back. Hope you managed to get something nice to drink or nibble on during that break. Okay, so we'll now leave the module system and the environment, the programming environment of ARCHER2 behind, and we'll move on to taking a look at the scheduler, the system that actually runs jobs does work on ARCHER2, which has got the lovely name of Slurm. So here we're going to go through writing job submission scripts, controlling jobs, finding out what resources are available on the system. And at the end of it, we're hopefully going to understand some basic Slurm commands, know the components of it, and know where to look for further help. So let's move this over a wee bit so you can see all that. There we go. So ARCHER2, as I've just said, uses the Slurm job submission system. This is termed a scheduler. And this manages the resources, which really, when we say resources, we really mean the nodes, the compute nodes, and how they're made available to users. There are actually a good few commands available through Slurm to help you start jobs, examine jobs, cancel them, look at nodes, look at various components of the scheduler and manage them. We're only going to focus on a few of them because, well, any more than that would become a bit unmanageable. So we're going to look at sinfo, which shows us the state of the nodes. Sbatch is what allows us to send jobs off to be run. Sq lists what's currently in the queue, so that's everything waiting to run as well as everything that is running. Scancel lets us stop a job if it's running and remove it from the queue. If it hasn't run yet, it just pulls it out before it is allowed to start running. Salloc is one way of submitting interactive jobs, so we can essentially log on to a compute node and start working there just as we would do normally on a login node. And srun is used either within a batch job script to start a parallel program or within an interactive job session to do the same. So let's start off by finding out which resources are available. So the command we'll start off with is the first one we mentioned just before, sinfo. So if you just run it, and I should have noted, I mean, you probably spotted anyway, but all of the commands begin with S. So that's the sort of telltale sign of a Slurm command. So it begins with the letter S. If we run sinfo in our terminal, we get a lot. So this is basically listing every node or group of nodes that is in any given state, and it tells us what type of node they are. So we can see we've got, well, it might be easier if we look at these here. So we can see which partition the nodes are in. Partition is a Slurm terminology describing a group of nodes on the system. So two particular types of nodes we can think of that might be grouped into partitions are our standard nodes, which have 256 gigabytes of memory each, and also our high memory nodes, which have 512 gigabytes of memory each. And there are our serial. It looks like these have been, oh no, they haven't, so they're still there as serial nodes. So these are our data analysis or data visualization nodes. So these are partitions. Which type of node is it, almost, or which group of nodes does it belong to? Avail, Avail tells us, are they up or down, essentially? Time limit says, well, the maximum runtime. This doesn't actually mean anything here because we use something else called a QoS, which we'll talk about in a little bit to set that instead. Then how many nodes are in each line, then the state of the nodes. So are they draining? So if they're draining, it means no new jobs are allowed to be run on there because they're being taken out of service, possibly for maintenance or another reason. Down just means they're down at the moment. Maintenance means they are in maintenance. Reserved, these might be our nodes, I'm not sure. Allocated for jobs. Idle means they're not doing anything. And then finally, these NIDs are referring to the nodes. So each node has a name, NID, and then a number. And if you log into a node for an interactive session, you'll see that the part of your prompt changes to that. So at the moment, where I'm logged in to ARCHER2, here in my terminal, I'm WLTA043, that's my user ID, at LN02, so that's login node 02. If I logged into to a compute node, that LN02 would become NID something. Yes, so we can talk about the partition, the status. You'd hope everything would be up, the node state, the node list, and then, yes, some various states that you might find the nodes in. Generally, most things will probably be in idle or alloc. Alloc is kind of where you want to be, where all the nodes are running jobs at the moment. Something you might have noticed here on the right is that this can output a lot of information. A lot of these Slurm commands can output big tables, essentially, of information. And at the moment, as you can kind of see, because I've got my terminal a little squished here, it can be a little hard to make out what's what. So one thing we can do to just make it a little easier to look at is the less-s command. So less is just, well, less is better than more. I guess that's why they named it less. We've used more just to look at a text file or or output and scroll through it. Less is similar, but it lets you go back, it lets you search and the like. And if we add the -S option, that forces single line non-wrapping mode. And oops. And okay, my screen means you can't see it, but you can, if you do that, if you try that yourselves, you will be able to scroll left and right on that, and the table will keep its correct shape. So you can just use the arrow keys to move about, see which columns line up where, and then when you're done, press Q to quit back to the command line. And that's even more useful if we do the next command here, sinfo-N-L, which is now showing us every node individually. If we run that, now we've got an awful lot of nodes to scroll through. We can go all the way through them. We can check out every node on the system, see its status, see what it's doing, and more. But yes, there are 5,850-ish odd compute nodes on the system, so there's quite a lot to look through, as we see there. So let's try and take a look at a compute node where we'll actually run. So let me quickly try and find out. Let's find a node. So you don't need to worry about this command I've just done. I'm just trying to find one of them that we're actually trying to use. Here we go. Let's see. So one of our nodes is NID. So here's one of our nodes. So this is a node that we have set aside for us this afternoon in our own reservation. So when we can run jobs in a second, we can send them to this reservation, and these nodes won't run any jobs unless they come from us in the TA043 group. So if we do sinfo -n, and then we've given it the node name 001512, and then say, let's just check %n, %c, %m. That's saying, I'm forgetting I'm not on a PC keyboard at the moment. There we go. C, %m. If we run that, we can see the name of that node, how many CPUs. Here, CPUs really means CPU cores, and how much memory it has. So there's a wee task now for all of us. Can we search for the nodes by state, and doing so find all of the free nodes in the system? So let's just take a couple of minutes, all of us, to try and do that. Remember, if you want to find out about how to use sinfo, a good starting point, man sinfo, take a look through all the options here, search through it with /, or if you just search on Google slurm sinfo, you'll be taken to the documentation from SkedMD who make it, and you can see there how to use sinfo. So I'll just let everyone take a couple of minutes on that, and then we'll see what people come up with. Okay, I think we only need a minute there. So has anyone managed to find anything? There's actually a neat little feature of sinfo you can use here to do this. A lot of the slurm commands allow you to narrow down information one way or another. Okay, so the method we can use is this just here. So sinfo-n-l commands is just what we used before, except now we're going to just add this extra flag to it, where we can say only show us the nodes whose state is idle. So if we take that, copy it across, we now find a list of all of the nodes which are idle and doing nothing. So again, yeah, checking the man pages of these is often a good start. And there are other Slurm commands which provide lots and lots of information. You can often choose to narrow it down, as I say, to certain states or certain types of jobs, certain partitions, certain QoSs. So I'm going to quickly talk about using batch job submission scripts. This is the most commonly used method of running jobs. The majority of people will only run batch jobs because it's convenient. You can submit a job to the system, log out, go home, and come back the next day to work and find that your job has run overnight. And hopefully you've got the results you were looking for, or hopefully if you're running a code and were hoping it wouldn't crash, you come back and find it hasn't crashed. So ultimately, a batch job submission script is a bash script, and it even starts with a little bash shebang at the top of it. Where they differ is that they follow with a header section with some special sbatch options, as we call them, passed through to Slurm. So these sbatch options, so when you actually submit the script, you would do sbatch is the command to use, followed by the name of the script, and that then sends it off to the Slurm scheduler to be run. Another little thing I found that sometimes catches people out if they're coming to this and they haven't done it much before is sometimes people will just try to do bash followed by the name of the script, or // then the name of the script. That won't actually run it as a job. You have to submit it through the sbatch option to see to it that it actually goes into Slurm, and Slurm puts it in the queue. And then when the time has come for it to be run, for it to then go off to the compute nodes to execute. So the beginning of your script will always start off with these hash sbatch options, and they set the parameters of the run. So here's our example script with this little XTHI program. This is what we're going to be running. So we need to provide some options to Slurm to tell it how to run it. So here's our shebang. Oops, you can't see that. There's our shebang at the beginning. Just says it's to be run as a bash script. And then we give it these sbatch options. We're saying we want the job to be called my MPI job. We want it to run on 2 nodes. We want it to use 128 MPI tasks per node. So that's 256 in total across both nodes. Only 1 CPU should be used to run each task. We want it to have a maximum runtime of 10 minutes only. So if it runs beyond that point, it will be forced to quit. It will be given a kill signal and exit. Setting it shorter helps it sometimes often to run sooner, because the scheduler can fit it in gaps in what's due to be run. Then we've got these 2 lines here, partition equals standard. And we saw a bit about partitions a minute ago from sinfo. Partitions say here, which nodes do we want to run on? Here we're just saying run it on the standard compute nodes. We don't want to run on the high memory nodes, and we don't want to run on the data analysis nodes. Then we've got a QoS line. So this is QoS equals standard. The QoS here stands for the quality of service. And it's a little like selecting a queue, say PBS scheduler system if you've used PBS before. QoS, the QoS that you choose determines how many nodes you can ask for, how many, how long it can run for, how many jobs you can have running at any one time, and how many jobs you can have in the queue at any one time. The reason that this exists as an option is to allow people different choices. So one choice that's you'll, because you're here in the developers course, might be interested in is the short queue. We'll talk about that in a little bit. We'll see how going for a standard QoS or the short QoS, they're each useful in different situations. Then we have this this line for the account. So this says -- account equals TA043. That means that when we run this job, when the job ends, the resources it took, so the number of CUs, which is ARCHER2 terminology, stands for compute units, it's equivalent to node hours. How many node hours should be deducted from the TA043 budget? So every project has a budget. If you want to run jobs, you need a budget. You need a positive budget at the moment on ARCHER2. Jobs aren't actually being charged just now, but you do need it to be positive at least. So this says, where should you charge the resources for the job? And if you don't give this, well, we'll see in a second. Finally, there are two slightly, maybe not as obvious options. Hint no multi-thread is essentially us turning off multi-threading, turning off hyper-threading, SMT, and whichever terminology you want to use, so that we are only running a single thread per core. Often running with multiple threads on a given core actually leads to a degradation in performance, so we're turning that off. And distribution block tells Slurm how to place the MPI tasks on the nodes. And this essentially means start on the first processor and go 0, 1, 2, 3, 4, all the way up to 63. And then on the second processor, start at 64 and carry up to 127. I think the default, if you don't do this, is round robin. So it sort of puts task 0 on the first processor, task 1 on the second, and then it jumps back and forth between them. This is better if to sort of make sure that you have tasks taking advantage of locality to one another. So those are VS batch options. So these options here, these are what we use to tell Slurm how to run our job. How many nodes, how long, and so on, how to charge it. Then the rest of the script is just a normal bash script. And this is where we actually do the running of the job. So we do a module load xthi. This is just something we can do in our regular login shell. We can just do module load xthi, and all that does is it takes the location where the xthi software is installed and adds that to the path. So we can now do which xthi, and it knows where xthi is located, and we can run it if we want. So this here is just saying, take the xthi software and get it ready to run by loading it into the environment. Then we set export OMP num threads equals to 1. Again, we want to make sure that there are certain pieces of software that try to take advantage of OMP num threads. Here we're just setting it equal to so that try to take advantage of OpenMP. Here we're setting this environment variable equal to 1, just to make sure that if there is anything that, in what we're doing that can use OpenMP, we are turning it off. We don't want to use OpenMP here. This is a pure MPI job. And finally, we run this little command here, srun xthi, to actually start it executing on compute nodes. And srun, because it's a Slurm command, knows about all of these options that we specified previously. It knows how many nodes, how many tasks. It also knows which nodes, and it can set everything up to so that the tasks we're launching are able to communicate easily, quickly with one another, and it will get things going for us. So this is the actual launch of the executable. This basically goes through everything I was just talking about. Yes, so we do have for this course a reservation in place. So what you should be able to do, if you want to try running this job, you can absolutely go ahead and do it. If you are working on a TA043 account that you've created for the course, what you can do is you can use our reservation. So that, and I'm just going to put it in the chat, will look like this. And let me quickly grab the name of that reservation because I've lost it. There we are. That's our one for today. So you can put this at the top in the header of your Slurm job script and just use the same standard QoS, standard partition. Everything else can be just as we have it here in this example script. And if you try to run that, that will then execute that job on one of our special reserved nodes. The reason for this is that the system is being quite heavily used at the moment. So even a short job of only a few minutes, if you come in at a bad time, you might be forced to wait a little while for it to start running, for it to get to the top of the queue. But because we have our reservation here, we can just go ahead and start running on one of those nodes instead. I'm actually just going to put that into the Etherpad as well. Let's just put it at the top of the Etherpad. So to use the course reservation. I will have a different reservation tomorrow. And I'll update that then. So this reservation is active until 4 o'clock today. And then the one we have tomorrow is active from 10 o'clock until 4 o'clock again. Okay, yes, so if you want to try running this, this little script here, you should be able to just create a file on ARCHER2. Remember, create it in your work directory, not in home, because remember, home isn't visible from the compute nodes. So if you go to your work directory on the work file system, just copy and paste this job script in. If you want to try with the reservation, just add that line I put in the chat into the script. And then when you're ready to actually run it, you just use the sbatch command. So you might, for example, call the file testjob.slurm, and then you can just do sbatch space testjob.slurm, and you'll get some output saying that it was submitted and what its job ID is. Something sometimes people have asked me is, do the job scripts have to have a certain name or naming convention do they need to be called? Do they need to have a certain extension at the end? I would say no, they don't. Really, this is up to you. I like to call things thing.slurm because then I can see immediately that it's a Slurm job script. Other people do things like run.sh because it is still a shell script, even if it's had the sbatch options added to it. Really, what's important, I think, is that when you're working, that when you do an ls in a directory or when you're trying to find a job script, that the name makes sense to you. So you could use a file with no extension at all, or .slurm or .sh or .bash, as long as you can look at it and go, aha, that's my job script. I think that's the important thing here. At the end of the day, you will do sbatch space whatever name you used, and that will be fine. Do any of the commands need to be enclosed with quotes? No, they shouldn't do. You should be able to just use that as is. Ah, do we have a QoS for it as well? Oops. Do we need to QoS reservation? Okay, yeah. Okay, so we need to add that as well. I think because the system's only been up and running for literally a week for most people, I think there are still a good number of changes coming through. So let's add that here as well. So we want to note that we also need sbatch. Thanks for testing that out. So we also need QoS equals reservation. Okay, great. And with that, hopefully, so I don't know. Let's just try doing SQ as well. So so if we run SQ, I'm just going to grep here for TA043. Don't see anything. If we just do SQ, oh no, of course it doesn't by default output the project. You can see there are a lot of jobs running at the moment. Okay, so constraint IV bridge 128G. Yeah, so that isn't part of the Slurm setup ARCHER2. If you've used Slurm a lot, and I guess you have, talking about Jasmine, you're probably aware it's incredibly customizable. You can set it up in, I don't know, many ways. And here we're defining the type of job almost purely through the partition, QoS, and if appropriate, the reservation as well. As for why constraint needs those speech marks, could be that it needs to look it up in a file. This is something now on the systems end of things. Okay, so I had a feeling we might overrun a little. I think this session needs to be in the timetable for a little longer. Let's take 5 minutes to talk about this here. So let's see if running the job from above, the example script, the first example script for running xthi. Let's see if people can examine what the defaults are, because there are defaults, not for everything, but for some things. So if you take that job and just try running it a few times, see what happens. You may find that you can't always even get the job into the queue. Other times you may get it in, and then you can use that to find out defaults. And there's another message. Just be aware that ARCHER2 and Jasmine differ in subtle. Yes, yes. It's always a process you have to go through, isn't it? When you go to a different system, you have to sometimes just spend some time learning the quirks of it, because you know, I'm sure you know how many types of HPC systems there are out there now, and all of them are set up differently because they have different hardware intended to be used in different ways by different user bases. So all of them will be different, you know, at least in small ways. I'll just give people, let's just go with another 3 minutes, say, on this little task to find out the defaults. I don't want to spend too long here. And if you see the fifth one, wall time, this is hard. It is actually tricky. So I think maybe we'll leave that and just take a look at the solution for that one. Kind of on the same note, because Slurm is so customizable, I think it can also sometimes make things a little tricky when you're trying to use it, because there are a lot of all the ways that there are to customize it. There are different ways for a job to fail. And that sometimes means, I think, that some of the error messages you get when jobs fail are quite cryptic. I think, let me just check, I think under ARCHER2 docs we do list most of those common reasons. Yeah, so sometimes you get strange messages about QoS max wall duration or the like that actually mean things like you're out of you're out of core hours to use CUs. Yeah, they are like elvish runes. They are, exactly. It can be really difficult sometimes, and I think sometimes when people see them the first time, they think, oh no, something's really wrong. And it isn't, it's just being very unhelpful to them, unfortunately. Okay, I think we can, let's just carry on here. This is interesting, but it's not exactly necessary. Yes, just like needing quotes around a parameter. Why does one parameter need quotes and others don't? I haven't got the foggiest, but Slurm says it must be so, and so it has to be. And again, I kind of will see here how to get the wall time, how to get the default wall time is not easy. So if you've been trying to do this, you can basically take the scripts that we had up here and just delete whole sections of it to try and see what the defaults are. So if you took that script and tried to do that and did things like delete the partition and the QoS and then tried to send the job through to be run with sbatch, you would have got error messages telling you that they have to be given. So your partition and QoS have no defaults. You have to say at a minimum something like standard for them. For your budget, again on how your project is set up, if you only have one budget, or if there's a default, then Slurm will use that. Otherwise, it will say, I'm sorry, you need to tell me which account, which Slurm account to use, which budget to use. Things like the next two are how many tasks per node, default number of nodes. You can do something like that with a script, sort of like this, where you can check Slurm num nodes and output that, and you would find that the default is one task per node, one node, and tasks per node. You would have been able to use Slurm and tasks per node. This is quite useful. This tells you that, but it only tells you it if it's actually been set, so you can't see the default that way. So instead, what you have to do here is you have to check the actual output from S1 XTHI in the Slurm jobid.out file that's produced from every run. I'm not sure I said that previously. Yes, every job run, every sbatch, when you get a job ID, produces a Slurm jobid.out text file that contains all of the output from the run. So if you check that file, you would see how many tasks XTHI ran with. And the final one, it says here that the wall time, getting the default wall time is hard, and it is hard. We can't do anything like we could do for the others if you want to find that out. Instead, what you've got to do is you've got to submit a job without a wall time, and then once it starts running, you've got to run a command like this. sact is a command that tells you about particular jobs. Say we want to output the time limit on it, and we specifically want to look at job ID 12345 in this case, and that would output the default time limit, which is 1 hour. So that's definitely trickier than just finding the default number of nodes and the like. You have to do a little more digging with the Slurm tools to find that. At any point, you can run the sq command to check what's actually running at the moment. If you just run that as is, you'll see every job currently running on the system. So what you might want to do is pass the -u option to just look up jobs belonging to a specific user. So I might do, in my case, I'm not running any jobs at the moment, but I might do WLTA043, and that would show me whichever jobs I have either in the queue or running at the moment. And you'd get output like this, telling you the useful bits of information. In particular, when you're waiting for your jobs to start, well, you'll see this column here. ST is the status or the state. PD means the job is pending, but you will also see R at some point. That just means that a job is currently running. It's in the middle of doing the work. And CG means completing, and this does mean completing at the moment. So it means it's come back from the S run, but processes may still be active and finishing themselves, and Slurm will be doing various cleanup tasks. It might be deleting temporary files that it's created on the nodes, just making sure that when it ends, that node is ready for the next job to be run there. There are other states that jobs can find themselves in, but almost all the time you'll find that they're in one of these three. Nodes list, reason, you'll see if a job is running, will give the list of nodes actually being used for that job. But until it's started running, it's going to tell you why it hasn't started running. Priority means that that there are other jobs with a higher priority ahead of it in the queue. So if resources are freed, those jobs will get to run first. Resources means that you're now top of the queue, but the nodes aren't available for you. And also, the time will come when you'll need to cancel a job for some reason, whether it's still waiting to run or running at the moment. You can just do s-cancel and then give it the job ID, and that will kill it and bring it out of the queue again. As we were talking about earlier, once you've got past the header section of your script, so with all the #sbatch commands that tell Slurm what parameters you want to use to run your job, you then get onto the script part itself. So this can be very simple. It can be a matter of just loading modules and then starting an application, or it can be very complex. You might be doing you might have the start of your script move data around before it starts doing work with it. You may do some pre-processing perhaps to decompose a simulation before it's run. It can potentially be quite complex. Things that you really always have to do are you have to load software modules or make software that isn't available a module available somehow. You need to be able to run whatever your job is, and to make sure that the rest of your environment is correct. And yeah, as it notes here, OMP none threads should always be set to 1, even if you aren't using OpenMP, just to make sure that anything threaded doesn't try to thread. And after that, usually it's a matter of running your application, and that starts the Mpi Task Launch. So this will run on the head node of the job, but this srun command starts the parallel application up with the correct number of tasks on each node in the job. It pins them correctly to the cores and puts them all in the same MPI com world and so on, and gets things going. So yeah, at its simplest, you can just do this, srun xthi for the xthi example. I'm going to breeze through this a bit rather than have us treat this as an exercise, because I think we need to carry on a little bit. So something you may often want to do is to underpopulate nodes, particularly if your application needs a lot of memory per core. So ARCHER2 has a lot of compute throughput with its 128 cores per node, but that at the same time means that each core on average has around about 2 gigabytes of memory only. So if you're running something that is fairly memory hungry and needs more than that, you may want to see about underpopulating instead. There are other reasons, but that's a very common one. So when you're s-batching your program, you may want to run with fewer than 128 tasks per node, and you may want to distribute those tasks in a particular way. So I'll just go straight onto the solutions here. So your options that you would give to SBatch, so if you wanted 4 nodes with 64 tasks per node, that's fairly simple. You would just say to SBatch, give me 4 nodes, and on each of those in tasks per node, run 64 tasks rather than 128. You can then go down to the level of saying how many you want to run per socket by adding an n tasks per socket option. So here we've got 8 nodes, but we've only got 2 tasks per node, and each one of those is going to be on its own socket. Then finally, if you want to have 32 tasks on 4 nodes, and we want to put those evenly across the 8 NUMA regions on the node, 4 per processor, so 4 per socket, if you like, then you would split it up this way. So you'd say, well, I've got 4 nodes, I've got 32 tasks on each node. We're just going to put half of those on each socket, so 16 on one socket and 16 on the other. And then per task, we're only going to have, so per CPU, we're only going to have, sorry, I'm getting this all the way around. We're only going to have 4 tasks, 4 CPUs for each task, and that's going to space them all 4 CPUs apart from one another. Another common run method is for hybrid type jobs where you're using both MPI and OpenMP. So you've got tasks running through MPI, and then each task can run many threads through OpenMP. And that's the sort of thing when you might want to do this sort of setup here, when you would be spacing your tasks apart from one another to make sure that those threads do have their own cores to run on. So SBatch options are again the way to do it, just the same as before. CPUs per task is generally will generally do this job for you. So if you specify that CPUs per task is the same as OMP num threads, that will mean that that each task will be spaced that many CPUs apart, that many cores apart, and that those cores between the tasks should be used for the OpenMP threads. And yes, specifying threads per core is good here to make sure that you don't start doing SMT, which, as I mentioned earlier, is generally not that good for performance. So we've got an example script here. So we're now running across 2 nodes with 8 MPI tasks per node and 16 OpenMP threads per MPI task. That means that if you multiply those together, you do get all 256 cores being used. And so you can kind of see we've just put in the options we were just talking about. 2 nodes, 8 MPI tasks per node, 16 tasks, 16 CPUs per task, and every thread gets, every core gets 1 thread. And again, the next important bit is this here, that OMP num threads should be equal to 16. And that makes sure that that we're getting our 16 OpenMP threads running on those cores. Because of the memory layout across the nodes, this generally leaves us with certain setups being preferable to others. Really, this comes down to choosing one of these 4 options most of the time. So you might have 8 MPI tasks on each node, each with 16 OpenMP threads. So that gives you 1 MPI task per NUMA region. And then the other 3 ways just add more more MPI tasks to each NUMA region. As soon though as you start to spread your threads across multiple NUMA regions, that's where the NUMA distance for the memory of the threads working for the same task can become higher. So that's where you can see things start to slow down again. So generally, you only ever want to have you only ever want to spread your threads for one task over one new region and no more. Oh, as I mentioned earlier, your standard output and standard error from each job is written out to a file called slurm dash and then the job ID .out in the working directory for the job, which is normally the directory where you dispatched it from, unless you do something in the job script to change that. That's often one of the things that you'll be asked for. So if you find yourself having problems running jobs and you get in touch with the service desk, often they will ask you for the contents of this file and generally also the job script itself, at least to help with the initial diagnosis. That's just the default name for the file, slurm job ID.out. If you want, you can separate them out with -- output and -- error options to your sbatch header in the job script to send them elsewhere to named files of your choice. Other useful information. So really it's just interactive jobs. So what you can do is you can start an interactive job. Now I'll actually just quickly try this to show you. I'll see if I can grab a spot on our reservation. So this is just a way of us running jobs interactively rather than through a script. So if I change the QoS to reservation, and if I add our reservation itself to this, I should be able to, oops, I don't need the sbatch there. I should be able to grab 2 nodes for myself for a maximum of 10 minutes. So you can see here, all of these options that I'm giving to salloc are just the same options that you would be giving in a job script to the sbatch, hash sbatch header at the top. So if I just start this now, it's given me actually a very useful warning. So you can see it's actually telling me that at the moment I'm on the home file system, which isn't available from the compute nodes. So now that's gone through and it's told me that my job is ready. So I'm now in an interactive job session. It's told me I've got 2 nodes, NID 001512 and NID 001513. And I should be able to, if I do module load xthi, to make that available. And I can now do s1 xthi, and that should run, except of course I am on the home file system. So let's quickly change to the proper place to do this. And now if I just do s1 xthi, that will run on those 2 nodes that have been reserved for me, and I get the output. And then once you're done, so if I quickly do sq here, squ, and then my username, WLTA043, I'll see that I do have my job there running at the moment. This is my interactive job. I'll be charged for this just the same as a job script that I've sent into the queue to run non-interactively. So I'll exit it, and that ends the job. And if I now do that sq command again, we'll see that my job is no longer running. Another way to do this is to use srun instead. So it's another way of running an interactive job. I won't. Oh no, I will. I will show this to you. I will show this to you. It's a little different. So when we use salloc, we're being given nodes to run on, but we're still working on the login node. If we do an srun, I'm not sure. I'm not certain which way is really better. Possibly salloc is better because it's more like running a normal job. But you'll see this is just a little different. And I need the name of the reservation again. So I'm running on the reservation. So again, all these options are just the same as as the options that you give to sbatch. So I'm running on the standard partition with the reservation QoS on our reservation. I'm asking for 2 nodes with 128 tasks on each, and CPUs per task equals 1 for 10 minutes. And again, I'm on the home file system. I forgot to change once more. So let's quickly move somewhere appropriate once again. 043. Okay, that's good. I'm on work. So so this is now a little different. So the main thing you can see is that my prompt has changed. I was originally on N02. Now I'm on NID, so node ID 001512. So this is me now actually working on the compute nodes directly. So I can again though just do module load or indeed ml xthi to load xthi ready for use. You can see here the srun command is a little more complex. There is a reason for this. I'm not sure I want to go into it just now. It comes down to the fact that we're doing 2 sruns to launch xthi here. We're doing the first srun back in on the login node to start the interactive job, and now we're doing another one here. But if we want to do that, we've now got to add this oversubscribe option. Tell it how many tasks we want. So we want 256 tasks across our 2 nodes, and we still want our distribution equals block, and our hint to be no multi-thread. And then we can start xthi once more. Distribution block, I missed a K. And if we just give that a second to launch and then run, it runs. So you can see you can use both methods. srun is maybe the srun method is perhaps more useful if you are developing something and you want to see how it runs directly on the compute nodes. If you just want to be able to start a job to start a run interactively, see errors, maybe do a little debugging, run again without having to wait in the queue every time, I'd say maybe use salloc rather than srun. Both methods, once you've finished your interactive job, you can just type exit to leave, and you can see we've returned to LN02, our login node. So yeah, so I think these are very useful for developing when you maybe are expecting that something is perhaps going to crash a lot, or you need to vary input a lot. So you're expecting to run lots of very short jobs, perhaps in a short period of time. At that point, I think that would be when it would be really great to fire up an interactive job, and then you wait once for those nodes to be allocated to you, so you don't have to wait in the queue every time that you start the work again. You can just get your allocation, run it, see it fail, run it, see it fail, run it, see it fail, fix it, and now it runs, and then exit from your job. Similarly, something useful is using the short QoS. So we've been using, well, the standard QoS is the one that most people use most of the time. We're of course having to use the reservation QoS if we want to run jobs on our reservation. But another fairly commonly used one is the short QoS. This kind of acts like a separate queue. So there are special nodes, only a small number of them, set aside for the short QoS. 32, I think, at most here. And a short QoS also only allows jobs to run for at most 20 minutes rather than 24 hours. Very restrictive if you're planning on running big production jobs, but if you're trying to debug something, you very often don't need to run big jobs. You just need something to run quickly and again get back to you so that you can see what went wrong and hopefully how you can fix it. So in these cases, you would want to use the short QoS because things in the short QoS, because they have this special small subset of nodes set aside for the queue, jobs will run there, chances are, very quickly, hopefully immediately. And to do that, you would use the standard partition, but you would set your QoS equal to short. And you would need to make sure as well that you set your time to no more than 20 minutes. So 10 minutes would be fine. And also, yes, you don't use too many nodes. And you would then just submit that the same as before with SBatch, and it would almost certainly run, get to the top of the queue and run much faster than it would have if you'd put it through the standard QoS. Again, we'd need sort of a whole day probably, or at least a full afternoon, to get through all the different types of things you can do when sending jobs off to be run on ARCHER2. We haven't started using the high memory nodes. That would mean using the different partition. We haven't talked about running very long jobs. That's a different QoS. You can run job arrays, so lots of very similar jobs, perhaps doing the same thing but using different input directories. You can use Slurm to automate how those are run. You can have jobs chain one another with dependencies, so submit multiple jobs, but perhaps some jobs rely on the output of other jobs, so you can choose to have them only start once those jobs that they depend on are completed. And you can run subjobs within nodes, so you can have different things happening on different parts of a node using one job. But that's all in the documentation. So if any of these sound interesting, you can of course ask just now or tomorrow, or just take a look at the documentation. And I think at that, we will leave it there for this afternoon. I'll stay in the call for the next minutes or so until 4 o'clock because we've still got the nodes reserved until then. You can run jobs the whole time that you have this account, but you just might be waiting a bit longer for them to run without the reservation. So yeah, as I say, we've got the reservation until 4 o'clock just now. And then we have them again tomorrow for tomorrow's session from 10 o'clock until 4 o'clock. So yeah, I'll leave it there. Many apologies again for the internet difficulties that have been plaguing me. That was a very nasty surprise. I'll see if I can at all do anything about that this evening. But just for now, if anyone has any questions, please go ahead and ask them, and I'll do my best to help you out with them. of course, for anyone who is just leaving for now, thanks very much for coming. Hope you found it useful, and see you tomorrow. Perhaps best leave it as it is. Yes, it was a bit of a heart stopper when I was turning my computer off and on again, thinking that might fix things, and then I saw the red light on my router. You're welcome, Pavel. Thank you. I'm not sure. I'm not sure who when the when it will actually be made available. I'll see if I can find out for you. You're welcome, everyone. Thank you.
Yeah, just wondering whether I can catch up before tomorrow.
Yeah, I'm hoping you'll be able to.
I was able to submit some of those runs and stuff. So I clearly I was able to follow stuff. So
okay, great. I mean, the material itself is already available. It's just the video recording itself. But to be honest, a lot of what you missed was me panicking about my internet connection.
And is it available in just Archer's documentation, or is this? Are you saying about somewhere specific, somewhere special, or?
So go on the ARCHER2 website. Let me just bring that up. I'll put the link in the chat for you.
Okay.
Where is it? So it should just come up. It should just come up when it's available on the training page for this course, which you've probably already been through, possibly when registering. Where is it? There it is. Okay, let me just copy this into the chat for you.
Okay, thanks. Okay. Yep. And then there's the course materials. Is that where I would click? Yeah.
Yes. Yeah.
Yeah.
So
okay.
that will bring you through to the material itself.
And then I click the individual links there to get to the individual sessions.
Yes.
Okay.
Yes. So we've.
Oh, brilliant. Okay.
Yes. So we've stayed. Well, it's a little late, as I say. I think that final session on Slurm, I've actually added a decent amount of material to that for the update for the full system. And I think I possibly underestimated how long it would take to get through that. But we've just got through all of this material for today. So everything up to the end of session 8.
Okay, great. Thanks so much.
Hey, you're very welcome.
It was good. It was good to confirm that I was able to log on and get going, and clearly being able to run those scripts at the end, writing them myself and whatever, gives me confidence that I'm not way behind anyway. Brilliant. Thanks so much. See you tomorrow.
If you manage that, you're bang up to date. Okay, great. Thank you. See you tomorrow.